Hi, my name's Allison. I'll be going over problem 33. A network of 5 equal resistors R is connected to a battery E as shown in figure 19.60. Determine the current I that flows out of the battery. For part B, use the value determined for I to find the single resistor Req that is equivalent to the 5 resistor network. So here's a diagram that I drew, which is based off of the one they gave us, but then I added the directions and current and labels for each R for clarification. So the big arrows that starts at E and points left, labeling I, is a positive direction, which starts at E, goes left, up, right, down, and then back left. And then the tiny arrows represent the negative directions, which go right, up, left, down, right? And the starting point 0 is at like epsilon. So in order to solve part A, we could use Kirchhoff's rule and Ohm's law, where we use the loop rule and voltages add up to 0. So we use the equation I equals V over R and then make it to V equals IR, so that we could take the components of all the voltages and add them to 0. So the unknown variables are I1, I2, I3, I4, I5, and we're trying to find the overall I. Part A are given E, which is the total voltage. Its value is unknown, but we'll just use it as E. And we know the known values is R, which all resistors equal to R. In this problem, we're not given any like physical values, but representations, which we will use to find I and the overall Req later. So we could first derive the equations based off of Kirchhoff's loop rule. So here I drew 3 loops, 1, 2, and 3, and I'll just write the equations. So in the entire loop, all the voltages will add up to 0. So it will travel the positive direction and the negative direction. So I1R minus I3R minus I2R is equal to 0 for loop 1. Loop 2 is I3R plus I5R minus I4R equals 0. And for loop 3, since E represents the overall voltage, it must be positive. So we set E minus I4R minus I2R equals 0. And if you look at the diagram, you could follow like the different arrows and the loops, and then you'll get these equations. Then, using another one of Kirchhoff's rules, we could find the relationship between I1, I2, I3, I4, and I5, and I. It's like when it splits off. So here, you can see I splits into I1 and I2. So therefore, you know I equals I1 plus I2. And then you could see I2 splits into I3 and I4. So I2 equals I3 plus I4. And I4 travels all the way back up. And you could see I5 is equal to I4 plus I5 is equal to overall I. And then another equation you could get is I1 travels down, I1 plus I3 is equal to I5. So that's how you get these 4 equations. And overall, I'm going to label them 1, 2, 3, 4, 5, 6, 7 to explain the very complicated calculations later on. So here are them labeled. And now we're just going to find I in terms of E and R. So starting off with number 4, equation number 4, we're going to use I equals I1 plus I2, and I2 equals I3 plus I4, which is equation 5. So since we're trying to isolate one variable to find I, and we know I equals I1 plus I2 according to the first equation, we're going to first solve for I in terms of E. Sorry, not the first equation, the fourth equation. So we're going to substitute I2 because it's in a lot of the equations, and then I'm going to first try like getting rid of it. So I2 is equal to I3 plus I4. So we substitute 5 into 4. We get I equals I1 plus I3 plus I4. So and now I'm going to use equation 3. I minus I4R minus I2R equals 0. And reorder it to E equals I4R plus I2R. And let's call this 3A. And then I'm substituting I2 for I3 plus I4 using equation 5. So now I'm going to do equation 1 and substitute equation 5 into equation 1. So I1R minus I3R minus I3 plus I4R equals 0, and then I get 1a, which is I1R minus 2I3R minus I4R equals 0. So far all the equations aren't really like interacting with each other, but later on you'll see how like they connect, and we'll eventually substitute one another and finally go to I1. So now I'm going to use 3a that we found above here and then bring it down here and substitute the I2 since all of the equations don't have I2 right now. So E equals I4R plus I2R, and then now we substitute equation 5 into 3a, and we get a new equation 3b, which is E equals 2I4R plus I3R. I'm going to reorder it so it's in terms of I3R. Later I'm going to substitute that and call it 3c. I3R equals E minus 2I4R. So now going back to equation 1a that we found up here, we're going to do I1R minus 2I3R minus I4R equals 0. And now I'll substitute 3c, which is found just up here, for the I3. So I1R minus 2, so this parentheses is where I3 used to be, E minus 2I4R minus I4R equals 0. And then I simplify and I get, I'm going to call it 1b now, I1R minus 2e plus 3I4R equals 0. So now to single I4, we just need to get rid of, single out I1, we just need to get rid of I4. And equation 2 from the previous list, let me go back to it, right here, I3R plus I5R minus I4R equals 0, looks quite similar, like it could be manipulated into this and to get rid of I4. So I'm going to start off with that equation and substitute I5 with equation 6, where I5 is equal to I3 plus I1. So here I substitute I5 and I get I3 plus I1 R minus I4R equals 0. And then I simplify and I'm going to call this 2a. It's 2I3R plus I1R minus I4R equals 0. So now I'm going to substitute I3R with 3c, which is over here. So it's the same thing. And then I'll get 2b, which is 2e minus 5i4 plus ir equals 0. And now we compare our 2b and 1b, and they're quite similar, as you can see. I added the multiply by 5 and 3 so that they would equal to each other later on. But as you can see, it's positive 3i4r and negative 5i4r. So we want to make it the same number. So 3 times 5 equals 15, and 3 times negative 5 equals negative 15. So if you add the two equations together, they'll equal 0, and it'll eliminate I4. So here I did elimination, and then you get 8i1r minus 4e equals 0. And now you can find I1 in terms of e and r, which is I1 equals e over 2r. So now we found I1. And since we found I1 and I is equal to I1 plus I2, we just need to find I2 now. So I start with equation 3a, which is E equals I4R plus I2R. So this was the manipulated equation of number 3. And then now I substitute again equation 5, I2 equals I3 plus I4 into I2. Oh, sorry, I'm going to manipulate it. So I'm going to change it to 5a. So I'm changing I4 now, where I2 minus I3 equals I4. So I substitute and I get E equals 2I2 minus I3R. So this is going to be 3b sub 2 because we had a 3b before. I'm going to replace I3r by manipulating equation 1, which is I1r minus I3r minus I2r equals 0. So since it's 2I2 minus I3r, I can just leave I3 as negative and do I2r minus I1r. And then I get E equals 3I2r minus I1r. That's 3c2. And since we found I1, we could just substitute it with what we found. So I1 is equal to 3 over 2r. So we just do the math, and then we get negative I1r as negative e over 2. So we get E equals 3I2r minus e over 2. And then we just do some algebra, and finally we get I2 equals to e over 2r. So now we can finally find what I equals. I equals I1 plus I2. We put in the values we found, and it equals to E over R. So this is the current going into the circuit and coming out. So according to the diagram, I is E over R. So it goes up here and down here. So that's I, which is the current. And to find part B, it's a lot simpler. We just use the equation I equals V over R EQ. I labeled it as all, but it's REQ. So we know I from part A, right here, E over R. And we also know V is E. So all we're trying to find is REQ. So the known is I and V, and the unknown is REQ. So I is E over R, and V is E. I'm going to leave it in the form of I and V to keep things simple, and then substitute in the end. So this is it, and then I multiplied R to the other side in order to isolate it, so I get R equals V over I, and then I put E over R, and then you get REQ is equal to R. So therefore the overall resistance is equal to R, which is the given resistance of all the resistors. So this overall resistance is equal to one of these, yeah. So REQ is equal to any one of these R's. And that's how you solve this problem. Thank you.